A struct is an abstract data type. An abstract data type is one that you create. So you're creating a type. Remember, int is a type and string is a type. You got to create your own. And this is the earliest one. These are structs. And structs are just a collection of variables. So a whole bunch of variables belong to the same concept or the same entity, such as student would have a first name, a last name, a grade, point average, classes they're taking, and so on. All these different variables can be assigned to the same entity, a student. So that's what an abstract data type is, something that you create. We're going to learn the struct abstract data type, and in the struct you're going to create variables to hold different things. And then we're going to create variables of that struct. So we'll see how that's done. Abstraction, you'll hear this term a lot. Abstraction means a definition that captures the general characteristics without the details. And we've seen data types before. An int is a data type. A float is a data type. It tells the computer how to decode the ones and zeros at some location into a human readable form. We're creating new types that are abstract. A struct is a general family, a struct and then struct name. And then we have type 1, field 1, type 2, field 2. You can think of fields as the variable names. So fields are variable names. The types are there. Notice they are semicolon list in curly braces after the keyword struct and the name of the struct. The name of the struct will be the new type name when you create variables. Then a semicolon. So let's make some structs. I'm going to move my strings to a string function, and we'll make some structs. Void, do, C++, strings. I'm just moving my code out of main so I can play with structs and not have to deal with strings. We can hide it by just closing the display. All gone. All right, let's make some structs. General formula is struct and struct name because we're declaring types. Those are done outside of main. So it comes out here. Struct. Oh, I don't want to call this my struct. Curly brace. Semicolon at the end of the curly brace. And here we create them. We have int A, int B, string C. There we go. Expected identifier with the square bracket. Oh, instead of my struct and square brackets, there's no square brackets here. It should just be straight the name. There we go. Catch exception E, one warning, done. So that's how to declare a struct type. So this is a type. It's not a variable. It's a type. To create the variable, we need to use the new type we just created, just like in a type name when we create a variable. So we've created ints before, like int A is an int. We can make this struct. It's now a my struct type, and we'll call it my st. So that's how to create a variable of that type. The type is my struct, which was defined by the keyword struct, and then the name of the struct. Thank you. So now we've created it, we've declared it, we've created an instance of it. The next step is to use the instance of it. We need to access the goodies inside to store values. Just like we can store a number in our integer, we can store values in my struct. My st.a gets the value 7. Let's make it an 88. There we go. Then we can print them out. Cout a space and my st.a. Run it. And we should see a 7 and an 88 show up. There it is, 7 and 88. See, it's working. So we can use the different, they're called members, inside a struct by using the member access operator. The member access operator is the period. So use a period to access the different members and then the name of the member. And we can access them just like variables. So now I can write to my struct A. I can write to my struct, the string part, what is it called? C, or st.c equals hello world. And we can print that guy out too, just like we print out my struct A, C out, my struct C, end line, running it. We see our hello world show up. But if we try to print the struct directly, we get gobbledygook. Let's try that. C out, my end line, right? No member access operator, just the whole struct. And we have two errors here. And the first error says, oh, up here. There is no function called the insertion operator. These are the two alligators that take a my struct. So it does not know how to print a my struct. Right? And there is a way to tell it. And here we have to use a friend of my struct. So let's make that. Let's see, what is this? This is a O stream ampersand operator insertion open parentheses O stream ampersand let's call it oster comma my struct ampersand my str, and let's make it constant struct. And this is just going to oster inserts hi there and then return oster. Now those errors are gone. Look, errors are gone. And when I print it, it's going to say hi there. Hi there isn't the struct. Say hi there. But it runs now. And we can, instead of printing hi there, print some actual stuff, such as the different bits of the struct. So we can say oster gets the open curly brace string. It knows how to print strings, and it knows how to print A. So let's put a space. No, let's not put a space there. And then A, and then a comma, and then a B, and then another comma, and then a C, and the closing curly braces. Oh, not quite right. Meister.A. Meister B, Meister C. Now it's working. Run it again. And now it prints the struct, the whole struct. There's 88 zeros empty and then hello world, 3 bits of the struct. So this is an example of how to create operators. We created a new insertion operator because the old one didn't know how to do it. And now we can print my structs, otherwise this doesn't work. But you won't get that until a long time, so I can just comment those things out. That will be coming for you later. Not in this course, in a later course. Goodbye. Alrighty, so again, a struct is an abstract data type. Here, this struct is an abstraction of a student concept. That's the name of the type. And the student has a student ID, has a student name, has a student year in school, has a GPA. So those are the different bits of the student, or attributes or members of the student. That's how to declare it. And then to use it, we use the address of operator. Well, here's some conventions. Structs normally start with an uppercase letter, and you must have the semicolon after the closing braces when you declare the struct. What happens if you don't have it? Let's find out. We should get an error. There it is, expected semicolon after definition. Semicolon. There we go. Struct declaration does not allocate memory or create variables. It just declares how to read a chunk of memory um, with some label. To define variables, use structure tag as a type name. So student bill. So here we're creating a variable bill of the student struct. So bill is an instance of the student struct. Bill has a student ID, a name, year, and school, and GPA in memory. So once we create a variable of the abstract data type, we now actually have memory that we can write into. When we declare the abstract data type, we don't actually use any memory. So this does not use any memory. Well, doesn't allocate memory for our variables. Here are we, 724. We've been going a little less than an hour. Next one, accessing structure members. I talked about the member access operator. That's the dot. It's called the member access operator. And we use it after the variable name of that struct type to access the individual fields or the individual members inside the struct. So again, the period is called the member access operator. You've created a instance myst of the mystruct class, or not class, mystruct. And mystruct, if we look at the declaration here, has an A, a B, and a C member. I'm going to hide my O stream. And we can access each individual member with the member access operator, the period. We can access to write, as I do on line 38, or we can access to read, as I do on line 40. Just like you did with arrays. Now they have their own names. Each memory location has its own name and its own type, which you declare in the struct declaration. All right, so we'll skip that one. Display constant of a struct variable must display each field separately using the dot operator. So here they're going through cout bill doesn't work, and we saw the error that it gave. It says, I don't know how to print that struct. Right there, I don't have an operator that does that. So if I uncomment that, we get the error again. All right, we got two errors. The very first one says, I don't know, I don't have a function called operator insertion that takes a struct as the left-hand operand, or sorry, right-hand operand. But we can certainly declare one. And here we declare an O-string operator insertion that does take a struct as the right-hand operator. And then it'll work. But right now it doesn't work. So we're going to comment it away. Instead, the slideshow is suggesting that you print each individual member individually. So here's I'm going to put 2 slashes in front of this, turn it to a comment. We can get the student ID using the member access operator off of bill. Student ID is a double, and cout knows how to print doubles. Cout knows how to print strings. Cout knows how to print ints, I guess. And cout knows how to print doubles again. Oops. What's that one? Comparing structs. The equals won't work. The equals will work if you're comparing aliases of the same struct, but it won't work if they're different. Instead, you must compare on a field-by-field basis, unless you define an operator equals. So if we make 2 structs, my struct and your struct, then the equals won't work. See if it works. 3 errors. Always go to the top error first, because the errors propagate. Oh, and so on to parentheses. Do this first. 1 error. Okay, went better. This error says there's no match for the operator equals. The equals has not been defined to compare 2 structs. You do that in the struct. A public. Boolean operator equals. and it takes as a right-hand parameter a my struct const ampersand other. And then we say if other dot a is not equal to a, return false. And we do if other dot b is not equal to b, return false. And we do if other dot c is not equal to c, return false. And if we get this far, then everything's equal. So we can say return true. We can also say if other equals, can I do that? No, I can't do that. We'll just leave it. 3 errors, so mad at me. Expected colon before Boolean. What line? Oh, maybe it's not Boolean. Maybe it's bool. Ah, there we go. Expected colon before bool. Straight. There we go. Strange. Okay. Zero. So my string is not the same as your string. Wah, wah, wah. Wah, wah, wah. False. Okay, there we go. So again, unless you do this fancy trick where you create your own equals operator, then you cannot compare two structs directly. Instead, you have to compare each of their individual bits directly. So here, inside the operator equals, I compare each of their individual bits directly. A and B are both ints, so you can compare them directly, and C are strings to compare directly. Thank you. Because strings already have identified or declared they're not equals. So that's the equals one. And how to get around it by declaring your own operators. Let me put my O string back in. Voila. All right, what's next? Struct variable can be initialized when defined, so we can put things into a struct. And notice we have the values going in the order they have. So I should be able to do that with your struct. So let's put values in here. So we're going to say equals, and we have two ints, 1 and 2, and then a string. Your luck. That works. It worked. Let's print it out. So here I'm printing my string. Let's print your string. Or sorry, structs. There we go. One, two, your luck. There we go. So we can use an initializer list to set it. We can also set each member one by one. So here we're using the initializer list for Bill. We initialize only some members. Again, they have to be in order. If they aren't initialized, then it takes the default, whatever that is. So let's make another one here. His struct equals 3 and 4. See out his struct. There we go, 3, 4, and the null string. That I didn't know. I always initialize everything. Excerpts from program 11.3. So here in this a program they're making, they have an employee pay struct. Has a whole bunch of stuff in it. Has the name of the employee, the number of the employee, pay rate, hours, and gross pay, so we can calculate things. Then they create 2 employees, Betty Ross and Jill Sandberg, with a bunch of numbers in them. Not everything. Looks like hours and gross pay is left empty, and probably later they calculate those and fill them in. Structures can be defined in arrays. So just like we can make an array of ints, you can make an array of structs. And we should be able to initialize them. Individual structures accessible using subscript notation. Fields members within structures accessible using dot notation. So let's play with this. We're going to make an array of structs and fill it up with stuff. So we have my struct. This array of struct, we call it my star of unknown, gets the initializer list. Struct number 1, 1 and first. Struct number 2, 2 and second. Let's do 3 of them. Struct number 3, 3 and 4. Let's do -3. 3 and -3 and 3. And let's print these things out. For my struct ms in my star cout ms endline. See what we get. There they are. 1, 1, 2, 2, 3, 3, first, second, and third. So we can make arrays of structs. We can also access individual members in an array of struct. So was this my star, the middle member, and we want to get out its B and print it. We want to set it to 77. There we go, my favorite number. And then we're going to print it. Cout my star of 1. There you go. Notice I changed the 2 in my second element of my struct array to a 77 by accident. So I have an array, my str. I get the second element at index 1. I get a member of that struct. That member is B, which is an int, and I assign it the value 77. So that's how we access the different members of an array of structs. Fancy, huh? And here on the slides, they do it down here at the bottom. Cout student list of 5. That's the 6th student in student list. Dot student ID. So they need the student ID of the 6th student. Here's an example we're going to ignore. 11.6. Nested structs. So because structs are a data type, and when you declare a struct, you can have data types inside the struct. The struct has 2 ints and a string. We can put structs inside structs. So let's make I don't know. We'll just look at the slides. It's starting to get complicated for me. Here we have struct person info, has a name, address, and city strings inside it. Then we have a struct student, and inside the struct student is a person info. Then there's accessing. So let me grab this stuff here. We're going to paste it into my code so we can play with it. So I don't want to take the time to dig through this. I'm going to go after my OStream operator. Put it here. Spread it out. And we want to create a student and fill in the personal info of the student. So to create a student, let's do that. Down here, after I create my struct, I'm going to create a student, which is a struct inside a struct. So student S gets the struct. Now what's in a student? A student has an int, a personal info, a short, and a double. An int, a personal info, which is a short, not a person, an int, person info is next, and then a short, and then a double. So there's the short and then the double. And I missed a bit. Like right after the 7, we have a personal info. And the personal info has 3 strings in it. Is that right? 1, 2, 3, name, address, and city. Name, address, and city. See if this works. Expected comma. Oh, I need a semicolon here at the end. All right, it worked, but I can't print this because I have no printer for it. So let's print out cout S of what is it? Personal info, person info, or P data. P data, and inside P data we have city. There it is, city comes out. Notice how we get to the city member of the personal info member of the student struct. Student struct dot for member access. We get the P data field or the P data attribute. P data is itself a struct. And so in P data, we have members. So we use the member access operator of P data and get the city field. You can put a whole bunch of dots on things, far deep as you want to go. So again, a struct, if we go look at the initial simple struct, a struct contains variables of different types. And you access those variables using the member access operators, just a period. And then the name of the variable that you want that's in the struct. And because structs can have types in them, and the struct itself is a type, we can put structs inside structs. So here person info is a struct, and student is also a struct. A student has a person info as a member. So when we go get it, to print it, my student has a personal info as a member, and personal infos have strings as members, and so on. And that's really useful. You can make a hierarchy of data types. Use the operator multiple times to refer to fields of nested structures. So here they got like student personal info and the name and city and so on, and they set them individually. Whereas I use as an initializer list. Notice that the member that is a struct is itself used with these curly braces. So here's the student struct, and inside this student struct is the personal info member. And inside the personal info member is the city string, and so on, in the right order. So again, it has to be in the right order. You guys getting tired yet? Yes. All right. So let's do something more fun than this. I'm going to stop this or upload those 2 things, and we'll play with the lab.